A function. The idea of a function is very important. It has to do with a special type of pairing. For example, what's a pairing? Cause, effect, question, answer. Function is a special pairing. A pairing such that each input is paired up with a unique output. So this 1 leads us to this 2. This 5 leads us to this 7. This 6 leads us to this 7. This 9 leads us to the negative 1/2. Since each of the x's led us to a unique number, or paired up with a unique number, this is a function. Notice this one, that's not a function. This one's not a function because the 3 led us to negative 1. 5 led us to 0. And then 3 led us to a different input that it had led us before. So since one x is paired up with 2 different y's, it's not a function. The restriction's not on the y. Notice the restriction's on the x for a function. Determine whether each equation is a function. So here is an equation. Does this represent a function? Well, pick any x you like. Okay, x equal 2. So I replace the x with a 2. I simplify, and it gave me a y equal 3. So what you look for is, when you gave it a 2, did it give you just one y? Yes, it just gave me one y. So this pairing is unique. This x leads you to a unique y. This is a function. So it is a function. Here's another one. Let's test to see if this is a function. So let x equal some number. Let's say x equal 2. So replace the x with a 2. Take the square root, so you could cancel this power of 2. But remember, when you take the square root, you have to put plus minus. So this x equal 2, produced this y, and it produced a different y. It could only produce one unique y. Therefore, this equation does not represent a function. Domain is a very important idea too. All x's are okay except those that provoke a division by 0 or a negative under the square root. So let's find the domain here. So notice we have a denominator. We want to make sure the denominator doesn't become a 0 if we give it a certain x. So we tell the denominator x plus 3, you cannot be equal to 0 because you can't divide by 0. Then solve for the x. And so this x can be everything but a negative 3. Because if it was a negative 3, we will have a division by 0. A picture of that would be, put an open circle on the 3, everything that comes before the 3 up to negative infinity, and everything that comes after the 3 up to positive infinity is okay. How do you describe that? You put parentheses. Infinity always gets a parentheses because you'll never get there. And then this one, since we cannot include the 3, also gets the parentheses. So anywhere from here to here, this section, up to before 3, you could pick your x's from there. Any value of x there will be okay, and it won't provoke a division by 0. Union, or you could say or. You could pick your x's after 3. All the x's after 3 and up to infinity are okay. You could put them in here and they're okay. They won't provoke a division by 0. Now let's find the domain for this one. This one is y equals square root of x minus 6. Remember, we cannot have a negative under the square root. So you tell it x minus 6, you better be greater than or equal to 0. Square root of 0 is no problem. Greater than 0 means positive, right? We can have negatives, but we could have positives or a 0. Solve for the x. Notice you just take the inside. You don't take the square. Just the inside is the one that's supposed to be positive or 0. So x minus 6 should be greater than 0 or equal to 0. Solve for the x. And that gives us that x is greater than or equal to 6. That means all the values of x that are greater than or equal to 6 are okay. How do you describe that in a graph, graphically? Well, since we're going to include the 6, you put a little bracket that tells the reader the 6 is also part of the answer. So from 6 to positive infinity. You could pick any number there. Describe it. Notice, since we're including the 6, you put a bracket all the way to infinity. Infinity always gets the parentheses. This is the domain. This is functional notation. You don't say f times x, you say f of x. The advantage of using this notation is that it gives you 3 pieces of information. It gives you the function name, the input value, which is a domain, and then the whole thing put together represents the output, which is the range. Now we're going to evaluate this equation using functional notation. This g of x can be replaced with a y. It means the same thing. So we're going to let the x equal -2. So everywhere you see an x, put a -2. Here they are. Simplify. Gives you these numbers. Keep simplifying. Now we know that g of -2 equals -17. Or you could say y equals -17. Let's evaluate this one. So f of x equals 6 minus x. So remember, these x's are like spaces or blanks we're going to fill in. So there's a empty spot, empty spot. Whatever you put in here, you put over here. So what we're going to put in here is m plus 3. So what we put over here is at m plus 3. So notice the x was replaced by an m plus 3. Distribute this negative. Combine, collect and combine. And finally, f of m plus 3 equals 3 minus m. This is a piecewise function, and the name tells you why. There's pieces. There's 2 pieces, but 1 equation. How do you use these? Well, if your numbers are less than 2, use this one. If your numbers are greater than or equal to 2, use this one. So find out which group of numbers your x belongs to. So f of 4, x would be 4. So where does the 4 belong to? Does it belong to this group of numbers or this group of numbers? It belongs to the second group of numbers. All those numbers greater than or equal to 2 are going to use this one. So we're going to use this one. Now that you know which one you're going to use, you plug in the 4 where the x is. Simplify, and f of 4 equals 13. Again, you could say for x equal 4, y equal 13.